So our topic of discussion is applications of exponential functions. And here we go. First, I'm going to show you the formula, and then we're going to talk about a very realistic situation in which it's applied. This is the formula, annual compounding. We're just going to talk about annual compounding for today, and then tomorrow we're going to talk about all different types of compounding. You've seen this formula before, right? Maybe so? Annual compounding. This big A over here is the ending amount. This P over here, this P, this stands for, it's a vocabulary term in finance. Starts with a P. Anybody know what it is? It's also the name of the person that heads the school. Yeah, the principal is your starting amount. Never ever want to lose that principal. All right, AKA. What's up? AKA the starting amount. R, guess what R is? R is the interest rate or the rate in decimal form. Don't forget that. Not in percentage form. It's in decimal form. And guess what T stands for? Yep, T stands for time. Here's the problem we're going to study for today. These are very real numbers. I didn't make them up. I wanted to show you how what happens if you don't take college seriously, the amount of money you'd be throwing away, and the price, the cost of an education. In 2007, 2008, true story, 1 year of college costed $23,712. You guys, that's about the same time period at which you guys entered into this high school, right? This was an annual increase of 6.3% from the previous year. Assuming the trend continues and each year it increases by 6.3%, we're going to build a function that models this behavior. We're then going to use that function to predict how much college should cost you when you graduate, and you'll decide whether we're coming close or not. C, we're going to decide, I'm not saying do this, but God forbid you actually had a baby this year, and you had to start saving for your child's education. How much would you be expected to pay for your child's education in 18 years' time? And then finally, part D, we're going to figure out when would the college be at least 50 grand. So here we go. A. Okay, so we're going to use the model that we just that I showed you on the other board. What's the formula that helps us make a prediction for the future? Could you fill it out for me? A equals, what's our principal, our starting amount in this particular case? Okay. Try not to call out the time, because some people want to respond to don't, and you can just remember the thing. What goes in the interest rate spot? Yep. Very nice. 1.063, because 0.063 is 6.3%. And then, finally, we don't have any time period. Okay. Let's do B. Find the price of 1 year of college 4 years from now. So this would be about the time period. When is 4 years from 2007 to 2008? Pretty much right about now. Okay. Let's figure it out. A equals 23,712. It increased at 1.063, and we have 4 years. Plug that into your calculator. How much should college cost right about $30,276 and how many cents? Would you say that's accurate, or is that completely off? That's pretty accurate. Suppose you had a baby today, right? How much would you be expected to pitch in per year? Also assume that you love this child, they worked really hard through school, right? I'm talking really studious, all honors, all AP classes. They got to the end of school, right? And you're like, you know what? I'm so proud of you, son. I'm so proud of you, daughter. And then your son or daughter goes, but Pop, but Mom, I want to go to college. Will you help me pay for this? How much is that first year going to cost you? Let's see. Let's see. Well, the starting point was today's price, or sorry, 2007, 2008 price. We assumed it increased at 6.3% per year for a total of 18 years, because that's the point at which your child would be going off to school. How much are you willing to supposed to be pitching in? $71,214.26. Oh my God.
Yeah, but if it was now, present day, it'd be like 90 something.
You love your son or daughter. You love your son or daughter. Do you think it'd be hard to turn them down? If they asked you for this and they had worked real hard? And that's the problem that we face, right? Your parents are going to have a hard time turning you down for college, but things are growing exponentially, and that's a real scary number. Real scary number. That's basically what you're hitting them with today. You know what I mean?
Yeah.
Like your full college education today for 4 years is like $100,000, right?
Yeah.
In the same way, you are hitting up your parents, right? Their full education costs almost $30,000, and that's what you're asking for in 1 year. Last part of our lesson, then we're done for today. At what point will your education cost at least $50,000 for 1 year? Let's see. Let's try and figure it out. A is going to equal 23,712 plus 1.6, increasing at 6.3%. Ooh, and I messed up because what am I supposed to fill in?
A.
I was supposed to fill in the A. A was supposed to be $50,000. Let me start over again. $50,000. It's got to be at least $50,000, so let's change this up. 23,712, 1.063 raised to the t. And we're going to try and figure out the time. So this got brought up in terms of problems. You wanted to know very specific points along the curve. And so mathematicians invented something called logarithms to figure that out. And that's what we're going up into next. This t, this variable, is in a really annoying spot. You can't divide to get to it. You can't add or subtract or multiply to get to it. It's annoying. You know what I mean? So we developed a new form of math called logarithms to help describe it. But we're going to learn about that at the end of the week. Since you don't know about logarithms, what's the Neanderthal way of trying to get to it? Yeah, guess and check. Let's guess and check our way to it. Let's guess and check our way to it. Somebody throw out a number for me. 23,712, 1.063 raised to the 12. So 12 years later, it's still not enough, which means, let's see, about 13. Does everybody know how to cut and paste using your calculator?
Yeah.
Second, and the entry button will just recopy what you wrote in, so you don't have to retype it. Yeah. And then so you push the 13, let's see. Yeah. Hey, leave her alone. I like how enthusiastic she is. After 13 years. 13 years. I wouldn't say t equals 13. I would just write after 13 years. This was meant more as a discussion-based question for us to talk and yell at each other about than for us to be solving real specifics.